Ladies and gentlemen, good evening. On behalf of IEEE ADSF SIGHT, it's my privilege to extend a warm welcome to each and every one of you to our weekly interaction program. As we gather here today, after our first interaction program on February 10, we embark on a journey of exploration and discovery into the realm of sustainable energy, particularly focusing on the techniques of harnessing solar energy. This is an interaction program held through Microsoft Teams until March 30 between 6 p.m. to 7 p.m. on every Saturdays. Now it's time to welcome all the staffs. I welcome past immediate chair Dr. Angela Indra, chairperson Professor J. Vino, vice chairperson Professor Dr. Nityavati, secretary Dr. Shanmugapriya, joint secretary Dr. K. Ajit, treasurer Dr. J. Perlson David, executive committee member of projects Mr. Sivaraman P, executive committee member Dr. Arunachala Perumal, executive committee member of external affairs Professor Dr. Vaideki Vijayakumar, executive committee member expert in deep sea fisheries Mr. J. Vincent J. IEEE ADSF SIGHT coordinator Dr. G.S. Udayakumar, IEEE ADSF SIGHT organizer of North Tamil Nadu Professor Dr. M. Murthy, IEEE ADSF SIGHT organizer of South Tamil Nadu Dr. G. Anadi, IEEE ADSF SIGHT organizer of East Tamil Nadu Dr. A. Mayappan, IEEE ADSF SIGHT organizer of West Tamil Nadu Dr. S. Sasikala, lead social media Mr. Darikesh, special invitee Ms. Catherine Vero, and special invitee Professor Benisha M. I welcome all the IEEE organizers and I extend a special welcome to the session handler Sivaraman P. Now I request Harshni to give a brief introduction on the chief guest. Thank you.
Hello everyone. It is my honor to introduce our esteemed chief guest, Sivaraman P. A young and dynamic engineer, Sivaraman possesses a wealth of expertise in power systems with a particular focus on renewable energy integration, grid impact analysis for EV charging infrastructure, and power quality analysis. As a dedicated member of various IEEE standards and task forces, Sivaraman contributes significantly to shape industry practices and ensuring the reliability and efficiency of our power systems. His involvement in national study committees of SIGOR further underscores his commitment to advancing power system technical performance and active distribution systems. Shivaraman's expertise extends to a wide range of renewable energy technologies, including solar PV, wind power, and battery energy storage systems. His contributions as an active researcher in renewable energy, microgrids, and electric vehicles have been instrumental in driving innovation and sustainability in our industry. Not only is Shivaraman a senior member of the IEEE and a member of the Institution of Engineers, but he also holds the prestigious Professional Engineer certification. His role as an ambassador for IEEE initiatives, including smart cities and PES5P powering the future, reflects its dedication to fostering collaboration and knowledge exchange within the industry. Welcome, sir.
Hi Harshini, thank you for your brief introduction. And then we can directly go through the today's session. I am welcoming all you to the second interaction program of IEEE ADSF SIGHT. So this program is mainly focusing on the renewable energy, especially the solar energy. So in our last session, I'm sharing my screen. Let me know once it is visible. Can anyone confirm whether my screen is visible?
Yes, yes. Yes, sir. It is visible.
Yeah, good, fine. So this program is aiming for sharing the knowledge about the solar energy, especially the solar PV system. So in the first session, I give some idea about how the solar energy is helpful for our day-to-day energy requirement and its various advantages. What are the applications or where and all we can apply this solar energy, and the solar energy map, and some other things I shared. So I'm continuing with that. So the today title is the technique for harnessing the solar energy. So in this lecture, in this presentation, I am going to cover two things. One is the solar micro inverter, and second one is the solar string inverter. So we will see the solar micro inverters in detail, and solar string inverter in a basic. Yeah. So I will just recall the last session. In the last session, we have seen that in solar energy harvesting, we can say in a broader perspective, solar energy we can utilize in two ways. One is the solar PV system, and other one is the thermal system. For the application of solar, we can use it for the electricity generation, heating purpose, then especially rural electrification where the electricity is not reached, then street lightings and solar water pumps. So about the solar PV system, it is used to produce the electrical energy. So, and its main components are solar PV panels, DC distribution box, inverters, and AC distribution box. About the typical block diagram, it having the solar PV array or panel, then inverter or power conditioning unit, and distribution panel. This will be our AC distribution panel. If we have the loads, then from this panel we can directly power the loads. If we don't have the load, then we can directly export the energy from the solar to the grid. So, and this is the two photographs which we see in the left one is installed at the uh, rooftop of the building, and the right one is installed at the shed in a railway station in our India. Then this one will be the DC distribution box. It has the fuses and surge protective devices. And this one is the inverter. The left one is the string inverter, which is made by Delta. And the right side and also this is the string inverter, which is made by SunGrow. Then this will be the net metering scheme. So net metering scheme is used to account the energy consumed from the grid and energy exported to the grid. So in a residential system like our home, if we have the solar PV system installed rooftop of our home, so how we are going to account the energy imported from the grid and energy exported to the grid. So in order to do that, the net metering concept widely used, so that we have seen. So the bidirectional meter is a net meter generally. So here it can able to account the energy consumed from this distribution network, that is the grid, to the load in one direction. In the another direction, we can able to see how much amount of in this way it is one direction, in another direction from the solar PV to the grid. So it can able to see the power flow, that is energy imported and exported to the grid. And we have seen the solar power India map, and also the installed capacity of solar PV system starting from 2010 to 2023. So in the 13 years of period, you can able to see there is a huge amount of installed solar PV, installed capacity is established in our India. And this is the solar map for our India. Here you can able to see uh, uh, this one will be the daily generation per kilowatt peak. How much amount of energy in kilowatt hour? 1 kilowatt hour equal to 1 unit. So from 1 kilowatt peak solar PV system, how much amount of energy we can able to get it? And different types of applications, solar PV applications, ground mounted, including floating and hybrid, then rooftop and off grid. So this is the breakup of the solar power installed capacity and state-wise solar PV installed capacity. Rajasthan is leading among all states, almost 17,055 megawatt of installed capacity they have. Then followed by Gujarat, then Karnataka, then Tamil Nadu, then Maharashtra, and Telangana and Andhra. So major solar power park. Last time itself, I told that uh, if the installed capacity of the plant, which is 500 megawatt and above, that plants are generally called as ultra mega power plant. So it's a solar plant. So it is ultra mega solar plant. So Badla is the park which having almost 2245 megawatt installed capacity, then followed by Pavagada solar park in Karnataka, almost 2050 megawatt installed capacity. Then this is the typical photograph of the Badla solar park. I hope you remember, if the solar installation is happened at a different location, then those locations are called as land parcel. Here can you able to see this is one location, this will be one location. Here can also can able to see some installation. So this is one, then here one, then this will be generally one. So these are all generally called as land parcel. So it will have connected to the substation. From the substation, the power is exported to the grid. Then this is the photograph of Kamudi Solar Park, Bavagada Solar Park. Then we have seen the solar organization. So I take you to the MNRE, Ministry of New and Renewable Energy, then Solar Energy Corporation of India, then Indian Renewable Energy Development Agency, and National Institute of Solar Energy. So how many of you have gone through this website? So can anyone turn on your mic, and can anyone tell about that, what information you find in this website and how it will useful to you? Rusma, can you able to turn on your mic and share your uh, learnings in the last session? Then Sriram or sorry, Rusma, yeah, please continue. Rusma, please continue. Sriram, or can you share your learnings in the last session?
Sir, I'll tell about the MNRE, sir.
Yeah.
Sir, the MNRE is a nodal agency. They help in promoting grid connected and off-grid renewable energy in the country, sir.
Okay. So I am suggesting everyone to regularly check this website once in a week, mostly in Friday or Monday every week, so that you will get some up-to-date information. Yeah, good, fine. Thank you. Then we have seen that glimpse of the large scale solar power plant. Here you can able to see these solar PV modules. If you, I hope you remember, I told you that if you are standing at this location, if you see all the 360-degree direction, you can able to find only the solar PV panels only. So solar PV panels in the area wise, it is very much bigger. And this is the solar PV panel installation. These structures are called as module mounting structure. Then this is the another photograph of this module mounting structure. I told that based on the number of panel installed, we can tell how many number of structure it has. 1, 2, 3, and 4. So this is called as 4P structure. So it means 4 panel will be in a row. So hope you will remember. Then this will be the inverter room IR in short form. Then this will be our inverter duty transformer. Then this will be our switch gear. So this device is called as mm, NFPA system, nitrogen based fire protection system. I hope you remember how this will work. I explained in the last session. Those who are all not attended the last session, you please go through the recording so that you can able to get what information I shared in the last session. So this will be the NFPA system control panel. Then this is our substation layout. Then this one is the inverter display. So inverter, this is 2.25 MVA inverter, it having two circuits. This will be circuit 1 and this will be circuit 2. So totally at the time it is generating almost 182 kilowatt. Each circuit is delivering 91 kilowatt. So from this slide onwards, I will take you through the today topics. So about the solar PV systems, so generally solar PV systems based on the application, we can say the rooftop solar PV system. So rooftop of the any buildings, it including the residential building or any commercial buildings like shopping complex, IT companies, or any other industrial system. So on the road, if we while going, we can able to see, right, there are so many number of factories we can able to see while going on the road. So those factories are having a huge rooftop area on their shed. So in those locations, we can able to install the solar PV panels. So from that, we can able to generate the solar power. So that power can be used to run the equipments in that factory. So generally, those systems are called as solar rooftop PV system. Then second one is the building integrated photovoltaic system. So in the last session, I have not included this building integrated photovoltaic system. So this one is one of the hot research topic. In this one, what normally we will do in a building walls, we will place the solar PV panel. So in the how this rooftop PV system and this building integrated solar PV system is different. In rooftop PV system, we will install the panel on the top of the building. But in this building integrated solar PV system, we will we will install the solar PV panel on the side walls. So in some application, there are PV panels with transparency is there. In place of the wall, we can able to use the solar PV panel uh, for the power generation as well as the covering that area. So this is the hot research topic. Some other foreign countries, they have some uh, installation with building integrated photovoltaic system. In Google, you can able to find some photos on that. Then ground mounted solar PV system. Uh, in the last photo, what we have seen it here, these are all ground mounted solar PV system. In a ground, these solar PV panels are installed. So this kind of ground mounted solar PV systems are specifically used for electricity generation and connected to the grid. So especially for generating the power from the solar PV system and exporting to the grid directly. So for that one, mostly we are using with the ground mounted solar PV system and floating solar PV system. So floating solar PV system in a water reservoir like a dam and lake, we can install the solar PV panels on it, and from that we can able to generate the power. So there are several advantages are there in floating solar PV system. So that I will explain in the coming sessions. So I will give some light about the rooftop solar PV system. Generally, this rooftop solar PV system will act as a DER. DER is distributed energy resources. So the distributed energy resources, what is mean by distributed energy resources? So normally our electrical power plants like hydropower plant, thermal plant or nuclear power plant, they are a large power plant mostly in megawatt capacity range. So those plants are installed very far from the city or very far from the load center where we are consuming the electrical energy maximum. So those plants are very far away and larger in capacity. On the same time, the DER is a distributed energy resources. Those systems can be installed very closer to the load. For an example, our residential building, we are having our household equipments like refrigerator, washing machine, TV, etc. So these are all electrical equipments. If you are installing the solar PV system on rooftop of our building, then this system is called as DER based system. So generally called as DER, distributed energy resources. Okay. So and this rooftop solar PV system suitable for most of the locations wherever the rooftop is there. It is a RCC rooftop or sheet based rooftop. Sorry, we can able to install this rooftop solar PV system to most of the locations. In a rooftop PV based system, we can able to use mostly two inverters. One is the string inverter and second one is the micro inverter. So I hope you remember what is string inverter, what is micro inverter. I explained in the last session. Hope you remember. Those who are not joined the last session, I will again touch upon what is string inverter and micro inverter in the coming slide. So typically the solar rooftop PV system in the range of 1 kilowatt to 100 kilowatt. In some locations, it's not 100 kilowatt, even it can go in 1000 kilowatt, that is 1 megawatt or 2 megawatt based on the area available in the rooftop as well as the load requirement. So how much load do you have in your premises, that is the residential home or an industry or office? So as of now, anyone have any doubt? Turn on your mic and ask your question. So try to make this session more interactive rather than I am explaining. Uh, I'm expecting you to open your mic and uh, interact with me. Yeah. There is no question. I will move further. The rooftop PV system. So generally, the solar PV system is like this only. So we are having solar PV panel, SPV, solar PV panel. Then we are having the inverter. So solar PV panel will receive the sunlight, that is photon from the solar energy, that is sun, and it will convert the the energy in the light to the electricity in the form of direct current, DC. So most of our electric equipments are in AC system. So we are having an inverter. So inverter generally will convert the DC form of the electricity into AC form of the electricity. If you draw a curve, this will be DC straight line, and if you draw the curve for the AC, it will be sinusoidal. So most of our appliances are work with AC system. So we are using the inverter to convert the DC into the AC system, right? Suppose we don't have any AC loads at all. Only we have the DC load, means here we can directly connect to the DC loads. So here inverter will not present here. So we can directly connect to the DC loads. DC loads. So only one thing we need to take care, that is the voltage. So how much is the load, DC load voltage? So that that voltage we have to taken care. Okay. So moving further, the rooftop solar PV system installed like this. This will be panel 1, 2, 3, 4. So like that, the number of panels will be installed on the rooftop. So we have to make how many number of panels we want for a particular system. So next session, I will explain about designing of a solar PV system for rooftop based applications. Don't miss next session, design of rooftop solar PV system, and next to next design of ground mounted solar PV system. Next session and next to next sessions are very important, especially the design aspects. Okay. And about the rooftop solar PV system with a micro inverter. Uh, Yeah, now I will explain about what is micro inverter. Here can able to see these are all a panel 1, 2, 3, 4 like that. There are series of panels were installed up to here. Can you able to see there is a box over here. These boxes are called as micro inverters. These inverters are called as micro inverters. So these inverters are installed for one panel, one inverter like this. So this is the panel 1. So it will be connected to inverter 1. So this will be panel 1 P1. This will be inverter 1 I1. So one solar PV panel connected to one inverter. That inverter is called as micro inverter. So what is the advantage of having micro inverter? So there are several advantages are there. So the first one is the tilt. So here in a solar PV system, there are there are several metrics are there. So the first matrix is called as tilt angle, TILT, tilt angle. So how we are inclining the solar PV panel with respect to ground. So this is the ground. So reference ground. How we are placing the panel. So the angle difference between the panel. So this will be our panel. So this angle is called as tilt angle. So in micro inverter, whenever we are using the micro inverter, we no need to worry about the tilt angle. Uh, in a central and string inverter, we have to maintain uniformly the tilt angle. So here micro inverter, we no need to worry about the tilt angle. Second one is the shading. So hope you remember in the last session I told that shading on the shadow falling on the panel in this location can able to see near to this panel there is a building. This is the building. This is the one of the shadow object. One of the object we can able to make the shadow. Sometime those shadow can fall on this solar PV panel. Second one is this tree and third one is this side building. So these three objects can able to make the shadow and those shadow can able to fall on this panel. Okay, so if we need to plan the string inverter for this location, then there is a constraint on the shadow free area. So first we have to calculate what are the area the shadow can able to fall. Those area we have to avoid the area which is left out. Those areas are shadow free area. In those area only we have to install these solar PV panels, right? Uh, when we are installing these solar PV panels in the shadow free rooftop area, those time we have to taking care of a concept called stringing. Those particularly stringing is applicable to the string inverter. Stringing in a simple words we can say stringing is a uh, connection of series and parallel of multiple solar PV modules and forming a group of panel is called as stringing. So there are requirements are there for stringing that I will explain in the next session. So those stringing we can avoid. Okay, if we have to in order to frame the stringing, we have to arrive the number of panels required in series and parallel. So those things we can avoid. So tilt angle shadowing, then third one is we can avoid, that is stringing. Okay. Then fourth one is orientation. So in this photo, you can able to see all the panels are installed facing in one direction. In this direction, all the panels are facing in one direction. Okay, so if we are going with micro inverter, we no need to worry about the orientation. One panel can able to focus on this direction, panel can able to focus on this direction, another panel can able to focus on this direction, another panel can able to focus in this direction also. In simple words, we no need to worry about the orientation. We can install the panel in any direction in the 360-degree. Okay, so these are all some of the advantages of using the micro inverters. And also last time I told about the reliability. If one string inverter or one central inverter fails, significant amount of power generation will get affected. Okay, for an example, 20 kilowatt solar PV, rooftop solar PV system with one string inverter of 20 kilowatt. If that inverter get failed, then 20 kilowatt it's out of, will go to the out of service. We will not get any power from the solar PV system. So literally the power output is zero until we are rectifying the fault or replacing the new inverter. But in case of micro inverter, suppose in this system, suppose if one micro inverters get failed, then we will not affected in terms of power outage, because other inverters are remain connected to the service. These are all the inverters are remain connected to the service. So we no need to worry about the reliability, because the reliability of the microgrid system is high compared to the string inverter and central inverter. Right? Then moving further, this is the actual photograph of the micro inverter. So this is the N-phase micro inverter. N-phase is the one of the company which manufacturing the micro inverter. The rating of this micro inverter is 670 watt peak. Normally string inverter come in kilowatt range, but this micro inverter rating is only 670 watt peak. So for this rating, we can able to connect one solar PV panel equivalent to 670 watt peak, one panel, or second option we can connect with two panels. So maximum of two panels. For an example, suppose three 30 or 335 watt peak panel, two number we can able to make. So with two number of 235 watt peak panel, so we are getting 670 watts. So that one we can connect it to this. So these are DC cables. So one will be positive, one will be negative. Then this one will be the AC output, 230 volt single phase AC. So this is the micro inverter. This inverter is very compact in size, so we can directly place below the panel. So like this, how the panel is placed below the panel, how this inverter is placed below the panel. Similarly, we can use it in any of the system. Okay, so this is the general single line diagram of the micro inverter system. So this will be the panel, one panel. So for on that panel, separate micro inverter connected to it. So from the positive and negative, the cable will be connected to positive negative terminal of the micro inverter. Then the AC output is connected to the common AC line. So that line will go to the AC distribution box, AC DB. So similarly, the second panel, third panel, fourth panel. So based on the capacity requirement, we can add the number of panels as well as the number of micro inverters. Okay, so this is a typical configuration of one solar PV system with one micro inverter. In some other applications, one micro inverter with two panels. This one will be panel 1, this will be panel 2. So two inverter we can connect. So this will be uh, one micro inverters for two module. Similarly, three modules, one micro inverter we can produce. This connect 1, 2, 3. These are all panels. Then like that, as per my knowledge, micro inverter we can use it for four modules as well. 1, 2, 3, 4. We can use it for 4 PV modules. So this will be solar PV system of the 4 modules. Then one micro inverter MI. Then it will give the combined output. Okay, so generally micro inverters are mostly available in the range of watts only. In the last example we seen, right, 670 watt. Okay, so the maximum it can go to a kilowatt. I have seen on micro inverter with 1.2 kilowatt. Okay, so in this micro inverter, if we can able to connect two panel, so two panel we can connect. So in 1.2 kilowatt we can able to connect 4 panel maximum. So if this micro inverter is get failed, that only the 4 panel is get affected, but other panels in the system like this, we are having so many panels installed on the rooftop. Suppose let's assume only these 4 panels are connected to one micro inverter and it will go to the ACDB micro inverter. Suppose if this micro inverter get failed means only these 4 panels only will get affected. Remaining panels are inactive and it can able to produce the power, right? So that's what I told. The reliability of the microgrid system is high compared to the string and central inverters. Then location of the micro inverters, as I told, we can go with multiple tilt angle. For an example, in a rooftop PV system with higher or different roof range, then we can go with micro inverter. There we can go with multiple tilt angle, then multiple orientation. So as I told, we can able to install this solar PV panel in 360-degree direction. So we no need to worry about the orientation. Then the location where higher shading is a concern. So if there is no shadow creating object is there in the nearby area, we no need to worry. If there are large number of area or higher shadow creating objects are there, then we can go with micro inverter. Then higher system availability, that is in simple words reliability of the system. Then building integrated photovoltaic system. As I told, building integrated system, in a building we are installing the solar PV panels on the wall. So there are certain constraints are there taking care of the DC cable from the panel to the inverter. So in order to avoid that, we can directly install the micro inverter. So those locations, it's very useful. Okay, so that's about micro inverter. Do you have any questions for the micro inverter? Kirtana, do you have any questions on micro inverter? Nakshatra, Prabhu. Okay, good, fine. If there is no question, then we can move further. About string inverter, what you are seeing in this photograph is the string inverter of Microtech make. It is 100 kilowatt string inverter. So in this beginning of this session, I told what is string. String is a series and parallel combination and forming the string. So that is called as stringing. For that, we are using the inverter. That inverter is called as string inverter in simple words. So here what you are seeing, right? These are all the terminals, DC terminals. So this will be mostly positive. This will be negative. So negative 1, 2, 3, 4, positive 1, 2, 3, 4, negative 1, 2, 3, 4. Like that, these are all the terminals. Then these are all the isolators. I hope these are all isolators to switch on and off the PV modules connected to the DC side of the inverter. Okay, so about the string concept, so I told stringing is a series and parallel combination of inverters. In this first one, you can able to see here 9 panels are connected in series. So this is called as a single string with 9 PV inverters connected in series. In the right side, one can able to see that all the 9 PV panels are connected in parallel. So this also called as a single string with 9 modules in parallel, right? For a string inverter similar to this, we have to form multiple stringing. Okay, so in the next session I will explain about MPPT, maximum power point tracking. So in that I will explain how to form the stringing, how to decide how many number of panels is required, how many number of panels we have to connect in series, how many number of panels we have to connect in parallel. Those information I will explain in the next session about this string inverter. Can you able to see this is the MPPT 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I think this is 280 kilowatt string inverter for ground mounted application. So these are all the terminals. So these two are the positive terminal and these two are the negative terminal for this MPPT. You remember the name MPPT that I will explain what is MPPT, how it will works. Those information I will explain in the next session. You just remember what is MPPT, how these things. Okay. So for this inverter, totally 12 MPPTs are there. So 280 kilowatt inverter with 12 MPPT. Okay. So the string what we have seen right in this example. So one string, no, it's one string we have to connect it to this MPPT. This will be string 1. This shall be string 2. Then totally for this inverter we need 12 strings. Okay. So for each string we have to arrive how many number of panel is required, how many numbers in series and parallel combination is required. That I will explain in the next session. Then moving further, what you are seeing in this one, this is the string inverter of SMA make. This will be the DCDB. DCDB. So here they are not using fuse. Here they have used only the MCB. Here is the SPD. Okay. So from the solar panel, the positive and negative termination will come here. These are all the positive and negative cable termination. Okay. So from this, it will go to, so for an example, if the cable is coming like this as an input, then it will go as the output to the inverter. Okay, so here inside that MPPT will be there. So how many number of MPT is there for this inverter? So accordingly, we have to connect this one. Okay, this is the inverter display. In this right side, can able to see. This is the 20 kilowatt inverter. Okay, so you keep in mind all the system rooftop PV system inverter ratings will be in kVA only, not in kilowatt. So mostly the rooftop PV system will operate at unity power factor. So 20 kVA is equal to 20 kilowatt. Okay, so you try to remember, always remember solar inverters rating is in kVA only, not in kilowatt. Okay, so if someone is saying, including me, 20 kilowatt means it is 20 kVA system operating at unity power factor, right? You always remember these things. Okay, so this 20 kilowatt inverter, when I have taken this photo, that time it is generating only 3468 watt. So it means 3.4 kilowatt only it is producing, because it is evening almost 4:30, I remember. So that time it is producing very less amount of power. So only the power is less. Okay, so this will be power in kilowatt. Okay, here you can able to see one option called day. So this unit is in kilowatt hour, kWh, kilowatt hour. So what it means, this 20 kilowatt rooftop solar PV system on that particular day, starting from 6 o'clock in the early morning to till I have taken the photo, it produced 50.68 kilowatt hour. So that what we have seen in that solar PV map, kilowatt hour per kilowatt peak. So here kilowatt hour is 50.68. Okay, here kilowatt peak is 20. Okay, can anyone tell 50.68 divided by 20, how much is the value? Can anyone calculate and tell? Can anyone say that? 50.68 divided by 20, how much is the value?
Sir, 2.534.
Yeah, it is 2.534. Do you remember the power map? So we have seen, right? Starting from 2 to 6, we have seen, right? Kilowatt power per kilowatt peak. So here it is 2.534. This is the factor we are getting, kilowatt hour per kilowatt peak. This is very less actually. Generally, it will be in the range of 3.5 to 5. This normally it will be like, so the country like our India, we are having more solar insolation. Mostly we will get 3.5 to 5 kilowatt hour per kilowatt peak, most of the location in our country. Okay, if you are cleaning the solar PV modules regularly, then we are getting this one. So the reason for lesser kilowatt hour per kilowatt peak here is dust on the panel. Okay, so what happened is that the solar PV panels were not cleaned in a regular interval. There are so much of dust accumulated in on top of the panel, so it affecting the solar PV generation, right? If dust is accumulated on the panel, or shadow is following on the panel, it will affect the energy generation from the system, right? So like this, we have to calculate how much amount of energy we are getting per kilowatt peak. Okay. So do you have any question as of now? If you don't have any question, coming to the comparison of the string and micro inverter, some of the points are module level monitoring. Module means panel. So individual panel is simply called as individual module. In string inverter, module level monitoring is not possible. Only string level monitoring is possible. At the same time, micro inverter module level monitoring is possible. String design or string sizing is mandatory for string inverter, but micro inverter is not required. That is one of the advantage of micro inverter. MPPT, it's available in both the inverters, so it is advantage of the both inverters. Individual MPPT per module is absolutely, it will not be available in the string inverter, but it is available in the micro inverter. Module independence, yes, it is highly possible with micro inverter. Module independence means one module with 330 watt peak, one module with 335 watt, one module with 350 watt peak. So that module independence is possible, highly possible in a micro inverter based applications. It is not much possible in a string inverter based applications. Then any tilt angle is only possible at micro inverter. It's not possible at string and central inverter. Efficiency point of view, string inverter having higher efficiency, and the same time micro inverter having lower efficiency. On the capital installation cost, string inverter is low cost. On the same time, micro inverter is high cost. Sharding loss, micro inverter prone to higher sharding loss. String inverter with lesser sharding loss. Then module degradation effect, it having higher effect on the string inverter based system. Let's say on the micro inverter based system. Soiling loss, that also high soiling loss means I told right, and dust accumulated on the panel. So generally those losses are called as soiling loss, that is high in string inverter based application and low in micro inverter based applications. And adding any module in the future in the system, it is limited in the string inverter. If any that is depends on the string design, available number of MPPT. So based on the availability only, any module we can add it additionally. On the same time, micro inverter, that's not a much constraint, we can add any uh, PV panels and micro inverters at any point of the time. So these are all some of the advantage of micro inverters. So that is the typical comparison of the string in micro inverters. So now we came to the end of the session. So in this session, we have seen that different type of solar PV system, that is rooftop PV system, building integrated photovoltaics, ground mounted system, and um, uh, floating solar PV system. I have given the detailed view of the micro inverters. We have seen the micro inverters for rooftop PV based application and its various advantages, and also we have seen what is stringing, the photographs of the string inverter MPPTs, and also finally we have seen the comparison of the string inverter and micro inverter. So in the next week, I am going to touch upon the designing of rooftop solar PV system. Also, I will touch upon the building integrated photovoltaic system. In this example, can able to see in the building wall, they have installed this solar PV panels. So these panels are generally called as building integrated photovoltaic based applications. So in the recent developments are transparent solar PV model that can replace the glasses. Here you can able to see there are some glasses are there in that building. So those glasses we can able to replace with this solar PV panel, right? Okay, so that's all from my end. So you can connect with me through YouTube and LinkedIn in this. You can connect with me in this link. right? So now it is time for the question and answer. I'm expecting everyone to turn on your mic and you can ask the question.
Sir, the micro inverters are suitable for large industrial uses.
Yeah, yes, some applications where even ground mounted system also using the micro inverter for the higher reliability requirement. So only constraint is that it will increase the cost of the system. So it is possible, but with higher cost. Yeah. Any other questions?
Sir, what about the accuracy of microinverters, sir?
What do you mean by accuracy?
Efficiency.
Efficiency, yeah. So efficiency of the microinverter compared to the string inverter is little bit less. I remember I explained right in that slide. I explained in this slide, right? So the efficiency of the string inverter is high, but at the same time efficiency of the microinverter is a little bit less. For an example, if the string inverter efficiency is let's say 96 percentage, then microinverter efficiency will be 91 percentage or 92 percentage. It is a little bit less. Yeah. Okay, any other questions?